Alright guys, what's up? Here we are in section 8 of chapter 2, the last section of chapter 2. Congratulations. And we're talking about things called vertical angles. And no, it doesn't necessarily literally mean these angles are going to go up and down. But you're going to see what these things are, how we use them in two-column proofs, and it's going to lead to a theorem that actually is one of the shortest theorems that we use all year. But notice what I just said, we use it all year. So let's get into this, and let's get a little example. No foldable for this. This is just straight up notes. So into your notes, let's draw this example. And this example is going to be used to prove something to you. So make sure it's written down. And here's what's given to you. A simple little straight line right here, simple little straight line right there with an angle 1, angle 2, 3, and 4. It says if angle 4 is 40 degrees. So if angle 4 right here is 40 degrees. The question says, what would the measure of angle 1 be? What would the measure of angle 2? And what would the measure of angle 3? Well, very quickly, you know that this thing right here, we can assume that that guy right there is a straight angle. So therefore, this whole thing right there is 180 degrees. So I can simply take 180 and subtract away that 40 from this 180 degrees. And that would mean they're supplementary for sure, all that stuff. But you would get 140. So the answer for this angle right here will be 140 degrees. Beautiful. Now, same exact concept would apply to this one right here. If I go angle 1, which is right behind this 140, and angle 3, this thing right here creates a nice little straight angle. So I could simply subtract and get this angle here to be 40 degrees. So this one started as 40 degrees. Beautiful. And this one is 40 degrees. Well, I should have picked different colors. Whatever. Deal with it. And then that means, back to this. If I keep going with the same argument, this is a straight angle, so angle 2 and 3 are supplementary, which then would mean angle 2 is 140 degrees. So that's cool. So very simple. Very, very simple with that. But we have two lines here that's creating 4 angles, and just from knowing one angle, we can get the other 4 angle measures, which is really, really cool. So let's go on to a definition. And I don't know if you guys know this or not, but back in the old Western days, they did all kinds of weird particular things. But back in, wait, hold on. Woo! Hold on, there's more to it. Woo! Wait. Wee! Okay, we gotta do it again. You know that. Here they come. Da, 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 da. Woo! Woo! Wee! So anyways, there was all these, yes, covered wagons and all that stuff. Has nothing to do with it. But back in the day, they did something in the old Western days, and even back way before this, called a duel. And what it was two people kind of stood like, and there's many different ways to do it, and it's weird how it all kind of came about. But here's the general idea. They would kind of stand exactly at the same point. They would start at the same point. So right here where their feet are, they'd start at the same point, almost back to back. And they would walk an exact pace away from each other. Maybe it was 10 paces, maybe it was 15, whatever. And they would walk in exact opposite directions. So it wasn't like they kind of went zigzaggy. They went in exact opposite directions on the cadence of someone else. So they walked exactly the same time. So they went 1, 2, 3, 4, 5, something like that. And they went real nice and slow. And then as soon as they got to the 10th pace, they would turn and fire one shot at each other. Now, typically most times this was not at all to harm the other person, truthfully, even though I know it was a gun. They were horrible shots back in the day. Some people were really good. But typically what happened was they were really doing it to show that they were the man. They were doing it because, you know, for nobility's sake, to kind of win the arm of a lady or whatever. Not an actual arm, but, you know, like courting them, I guess, or dating them, or wanting to marry them, or whatever. So the point is this, though. Let me recap this. So they started at one point. They walked in exact opposite directions. So it's not like this guy right here just all of a sudden said, you know what, I'm going to start right here, but I'm going to go like this, and then turn back around and like be right behind that person. That is a very unfair advantage. So they didn't do that. And nor, like I said, they didn't go They didn't zigzag and go over here and say, "What's up, horsey?" and then shoot. No, they went in exact opposite directions. Exact opposite directions. And then, of course, yes, they turned and fired their little water pistols at each other. Anyways, There's a reason why I said this, because in geometry there are things called opposite rays. And this is a definition that needs to go in your notes, and here's your definition. It is when two rays having a common endpoint and they extend in exact opposite directions. Well, that should look familiar now. There are two rays, like we just had two people, that started at a common endpoint, and they extended in exact, keyword, exact opposite directions. So it's like they start at some point like this right here, and if this ray is going to walk in that direction forever and ever, this ray cannot walk that way. That's not exact opposite direction. New. What it is, it's got to walk this way, exact opposite direction. So that right there would be an example, not this. Wish I could erase it. I just erased it all. So if one goes this way, and one, let me put the point right there, and one goes this way, exact opposite directions. These two things right there are called opposite rays. And you get it, opposite rays actually create a straight angle. Now, let's keep moving, and here's a scoop. With opposite rays and how these all work, you can see there's one ray going that way, there's another ray going that way. So they do create a straight angle. But here's the scoop. If we put another pair of opposite rays, so let's say we had 4 people that were going to duel, 2 going one way and 2 going another way. So let's say now I have one going back this way and then another opposite ray going that way. What it creates, guys, is actually 4 different angles, where this is angle 1, this is angle 2, we'll say, this is angle 3, this is angle 4. That should look very familiar to the picture that we started this entire video with the starter question back there on the chalkboard, the green screen I had. Why am I showing you all this, though? Because this is actually showing you something very important called vertical angles. And here's your definition of what vertical angles are. They are 2 angles whose sides form 2 pairs of opposite rays. So you can see again where I had my angle here, this being 1, this being 2. It's almost like they are back to back to each other. So if this guy's facing this direction, that's supposed to be an arrow, and this guy's facing this direction, you can see that they're kind of butt to butt, cheek to cheek, whatever, back to back. So those guys right there are vertical angles, and then these guys right here where I would put angle 3 and angle 4, because they're standing back to back. So those guys by definition are vertical angles. Now, if you go back to the example that we did at the very beginning of this video, if you remember, we had found that this angle over here was 40. It was given to us. What can we conclude about vertical angles? If you go back to that example, remember we started with this angle right here being 40 degrees. If you remember what we found this angle over here to be, look at your notes. Exactly. This was also 40 degrees. What do we know about these 2 pairs of vertical angles? Look at your notes. Yes, this was 140 and this was 140. So these 2 angles, this vertical angle compared to this vertical, these 2 guys were congruent and these 2 guys were congruent. Now this is all well and good, but it's the exact theorem of what these vertical angles are all about. So here's what it is. The theorem actually says, ba-bam, if I actually have vertical angles, then they are congruent. So theorem 18, yes, you're going to use it a ton of times in 2-column proofs, but it says vertical angles are congruent. And how it's written here on the screen is exactly how you can use it in 2-column proofs. Well, Mater, you're awesome. I know. Thank you. But that's exactly what you do. So vertical angles, you have to first observe that there's vertical angles. Yes, you assume that, just like you assume straight angles, although you don't have to put it in your 2-column proofs. You'll see it in your book too. But you have to observe that there's vertical angles, and if there are vertical angles, then you can immediately say in your 2-column proof, bam, those 2 angles are congruent because vertical angles are congruent. So there's your actual notes. Let's go to a quick example of a proof so I can show you how this works in a 2-column situation. All right, let's do it. So jot this down in your notes. Here's the given information. Angle O is complementary to angle 2. So where's angle O? That's up here right here. And angle 2. So those 2 guys right there are complementary. And angle J down here on the left, it's a little late, sorry, is complementary to angle 1. The deal is we're proving angle O is congruent to angle J. Well, right away, here's what I see. I see angle J and angle O up here are already stated to be complementary to these two angles. So if there's any way for me to get angle 1 and angle 2 congruent, then I can use my handy-dandy theorem. If two angles, O and J, are complementary to congruent angles, then these guys are congruent. Let's look at the picture. Where's angle 1 and 2? Oh, look at that. Angle 1 and angle 2 are actually back to back from each other. They're created by two straight lines, opposite rays, and that means they're vertical angles. Sweet! So let's do this in step 2. We can go right away and say angle 1 is congruent to angle 2, and my reason is this. Vertical angles are congruent. Bam, I forgot to give an information up here, sorry. That's it. That's reason number 2. Now, I'm not done yet, but that's reason number 2, because vertical angles are congruent. If you want to write it in conditional statement form, do it. If two angles are vertical angles, then they are congruent. Beautiful. So now we can conclude what we're trying to prove. Angle O is congruent to angle J. And again, I said the reason already, but it's if two angles are complementary to congruent angles, which they are up here in the given information, then they are congruent. Bam. So there's a quick example of using the vertical angles in a two-column proof. Excited to master this in class? You guys are awesome. Congratulations, by the way. This is the last section of Chapter 2, which means Chapter 2 exams coming later. See you in class.